Current initiatives you might have heard of are the 30 by 30 initiative to preserve 30% of the land area by 2030. Climate change is increasingly affecting growing season. It's affecting the natural refuge for birds and wildlife. And birds and other species like butterflies, which migrate across states and countries, are having a harder time surviving. Birds fly at night. You never know. They're impossible to see and track. Tonight, you're going to hear how you might get involved if you wish to track where birds and wildlife are coming from and going to. And so tonight, Sierra Club gives you an opportunity to take action. The posters which you came in the back and the flyers on the table are identical. There are opportunities to sign a letter to President Biden. Ask him to support full funding of the Endangered Species Act and to enact a whole-of-government approach to saving biodiversity and endangered species. And the action is very simple in two ways. One is there's a QR code on that flyer on the table near you, and you should do this and then pass it around. The QR code will automatically open to a page which you need to sign, complete, and send. Or you can enter the shortened URL. If your camera doesn't work on the QR, there's a few character URL. Enter that on your browser, and again, you'll open the page where you do this, and then sign up the letter to President Biden, endorse it with a personalized message if you like, and then send, and it's taken care of. So your assignment's simple, please do it. Pass that flyer around, and everybody should take action. Thank you.
Testing.
Very working. Okay. How many of you, and don't say a word, just raise your hand, how many of you have heard of Greta Thunberg from Sweden? All right. She got started when she was 16. By the end of her 16th birthday, the world knew about her. The world. 16. Well, we've got somebody that's coming up that may just do that. Okay, here's the thing I wanted to tell you. First, we're the Sierra Club. We got started in 1892. John Muir realized as the millionaires wanted to buy Yosemite. All they had to do was where it goes like this, buy that, everything behind this theirs, even if they don't own it. Well, John Muir and 4 friends got together. They sat around his kitchen table. They plotted and plotted. They came up with 350 people from California. They kept going. And key, get to know a powerful politician. The politician was President Teddy Roosevelt. And our fearless leader got Teddy to go on camping trips in Yosemite. You better believe the millionaires lost. Okay. Teddy was so enthused about this and everything else because they became really fast friends, John Muir and Teddy Roosevelt. Teddy was president, say, like 8 years. In those 8 years, starting like 1901, He saved more American land than all the rest of the presidents combined. That's how good he was. The Senate got so mad because they wanted to give away all these things to the rich friends. So they said, okay, 12 midnight is the last time you can give away anything. So 11:59, he gave away an additional 50 million acres. Oh, okay. Anyway, now our stellar person got started when she was 15. Her bus driver, school bus driver, was Mary Lanko, who was a good Sierra Club member, and she talked to Lara Zullo on the school bus about the environment, how important it was to join. So Lara came at 15, talked her parents into driving her to the monthly Shore Group Executive Committee, and she sat in, and I said, this is a together lady. Okay. So I said, Lara, I would like you to join the executive committee. She said, yes. Okay. Then a little bit later, we needed a political chair. I said, Lara, I would like you to be the political chair. She said, yes. Now, what does that mean? She had to contact congressmen, assembly people, state senators, and get them to come to a restaurant. They would sit on that side, we would sit on this side, and she led the discussion. She asked them environmental questions, which they knew about because they'd already answered the questions. She was in charge. Okay, so what did she do? Okay, she graduated. She finally can drive. Big time. Now, she is leaving, and I asked her parents, wouldn't you like to be on the executive committee now? Us? You mean, you want us? I said, yes, I do. Okay, now they're political chair and Sandy Hook stalwart, Fort Hancock. Okay, now, she went to McGill University in Montreal in the environmental area. She's got a master's in sustainability. She's doing really great, and she's with us today, and we've got a little certificate for her. The Jersey Shore Sierra Group confers our Distinguished Service Award to Lara Zullo for her service as program chair for her outstanding organization of the Science Mondays Lectures series at Brookdale Community College. And she's doing all this from Ottawa. She's organizing our speakers. She's in Ottawa. See, you can be anywhere in this world and get it together. Okay, Lara, would you give a little hello?
Dennis, thank you so much for your overview. I think you covered a lot of my journey here. I just walked in one of these days after talking with my incredible bus driver, Mary. And I was really inspired from the talk that I went to and just got involved in environmental sustainability from there. So even when I went to Canada, I studied at an undergrad in grad school, and now I want to work in that field. And I'm currently doing that kind of work in the federal government, and then on an extra time, I'm volunteering in politics related to green ideology, and also volunteering with clubs in Ottawa. So yeah, I really just want to say thank you to the mentorship that I've received here from everyone, George, Dennis, Stan. Thank you to everyone from the bottom of my heart for your guidance. Really appreciate it. And thank you to the audience for coming out here to support this program.
Let me not drop it this time. Okay, here's your certificate. Thank you very much.
Thank you.
Okay, her introduce the speaker now.
Thank you, Dennis.
This is Harold Zulu.
So tonight, we are hearing from a man who has come here all the way from South Jersey and of diverse accomplishments and backgrounds. You're going to hear from Scott Whittle, who is a photographic artist among the top nature photographers in the state of New Jersey. He has a Master of Fine Arts in Photography from the School of Visual Arts, is a fellow of the McDowell Arts Colony in Peterborough, New Hampshire, has published books of his photography of birds and of American deserts. He's a professional educator and tour guide, including for people looking to learn nature photography. And so we're hearing also from the Scott Whittle, who is an accomplished birder and bird expert. As a birder, he has held the New York State Big Year record. His team holds a U.S. Photo Big Day record, and he has birded throughout the United States. His expertise in birds especially includes warblers, and with his co-author Tom Stevenson, the Princeton University Press published their definitive guide to warblers in 2013. The Warbler Guidebook has a companion website that you can visit at thewarblerguide.com and a companion app for iOS and Android. So he is very up to date for all of you. And that app includes innovative features like a 360-degree view of each warbler, tools for identifying the species and sex, and tools for learning to recognize the songs of the warblers. But then there is also the Scott Whittle, who is potentially now advancing the science and conservation of birds, bats, and other wildlife for throughout our Western Hemisphere, from North to Central to South America. And his work can lead to the single most vast and cost-effective extension of something called the MODIS network, which is not yet an everyday name to people, but it will become, because the MODIS network is a way of tracking birds and other wildlife through something called nanotags, which instead of a band, it's applied to a bird with a radio transmitter on it. And the nanotag is unobtrusive and weightless enough that it can be affixed to any small or lightweight bird, including yellow-rumped warblers, as well as more substantial birds or raptors, owls, and bats. And once they're tagged, they can be followed, tracked wherever they go. And because there are MODIS receiving stations that can pick up these transmissions from within kilometers, their migration and other movements and habitat can be followed. So, and Scott's Cape May area company, Cellular Tracking Technologies, manufactures receiving stations for this MODIS network, which has been expanding its hemispheric range. And the MODIS network will now allow scientists, through open source data, to understand how species are adapting to climate change and hopefully showing resilience, as well as learning how we can conserve land, water, and species to help their resistance and to facilitate conservation at a regional scale. At Cellular Tracking Technologies, Scott is director of Project Terra. And Project Terra is developing a device, the Terra, that looks like a path light along your walkway, and that in fact can be installed anywhere in your yard or roof. The Terra can monitor conditions in your garden and soil, detect any birds in your area, even if they aren't nanotagged, identify which species is singing. It can stream the sounds of the birds indoors if you wish. And if it is a bird, bat, or other wildlife that has been nanotagged, it'll pick that up and transmit the data about it to a central repository from where it can be used for scientific and conservation purposes and research, and vastly expand the MODIS network all over. So if you're familiar with Doug Tallamy's homegrown national park initiative to get people to plant wildlife-friendly, pollinator-friendly, and native species in their yard, well, if you add to that mix a Terra device, then you have a way to identify what you're attracting to your yard and to have the benefit of science and conservation to boot. So ladies and gentlemen, we are lucky this evening to hear from Scott Whittle, the nature photographer extraordinaire, bird expert and conservation pioneer. Scott?
Thanks. I got the other. Told me to use this other microphone. So, welcome everyone, and thanks so much for having me. I am Scott Whittle, and I am indeed the director of the Terra Project, which is creating a bioacoustic and radio tag network across the globe, and it will be the first large-scale bioacoustic net of its kind. So we're going to really create this cool device. Tonight, though, what I'd like to do, in addition to telling you a little bit about that, is talk a little bit about just how technology is used to help us track and conserve birds in general. And so I thought what I'd do is start with the question, because I always find it's most interesting to learn things when you hear the question first. So rather than just tell you what we're doing, I'm going to go the long way here. So this is, oh, there we go. Good. I'm going to talk about 5 things that people have done in history to try to understand birds and where they go. So people have used observation, they've used banding, telemetry, community science, and now bioacoustics. So let's go back just a couple of years back. First of all, let me just show you this picture. This is, if you look at the top left picture, those are actually swallows in Cape May in the summertime. So they can form in these huge flocks. In fact, the tree swallow groups we get there can grow up to like 10, 20, 30,000 birds in a flock, and they'll hang around for maybe a few weeks in the late fall, and then they'll all disappear, right? They'll go, what we know now they do is they migrate. In the winter, you won't see one. You might see 1 or 2, but other than that, you won't see any, especially if it's a cold winter. You can imagine that nowadays we sort of take it for granted that we know that these birds migrate. But in the days before, maybe the last couple of 100 years, we actually had, and even 100 years ago, we really didn't know what they did, especially certain birds like barn swallows, which apparently were there and just gone all of a sudden. And no matter how far south you went or how sort of how far you traveled in the way that people could travel in those days, you wouldn't see it until they came back in the summertime. So the question is, where do they go? And that question has actually been a question we've been trying to answer for thousands and thousands of years, I imagine, since people first noticed birds. So there's a fellow that you guys might be familiar with who helped us understand that. And he lived in this area. This is the Roman Empire, 117 AD. So this is sort of one of the largest extents of the Roman Empire that it got to. And you can see that it's this huge area of land, especially for that time. It was a massive empire. And they were familiar with birds like this Egyptian vulture, which would migrate from Spain to Morocco. So the empire was big enough that they could actually notice it in both places at different times of year and say, okay, well, we think that these big birds might fly south to some degree, so they go to maybe warmer climates or something. But barn swallows, these little birds, they said, well, there's no way that these little birds were capable, first of all, of flying these extremely long distances. You have to be a big bird to be able to do that. And second of all, as far south as we go, we still don't see them. So they must be doing something else. So anybody know who this is, 350 BC? This guy actually started early on. Aristotle. He's, you guys might be familiar with him. He's contributed a couple of things to Western society, and one of those things was trying to organize and understand the living world. So he was actually one of the first taxonomists. He sort of created our first system of taxonomy and understanding how we should organize living things. And he had a few theories about what these swallows might be doing. So the first one was transubstantiation, I guess you could say. He thought that maybe what was happening was that these birds would actually change from swallows into another bird. And that's why we weren't aware that they were there. They had actually totally changed form. Now, it sounds ridiculous, right? Except that if you have ever seen the difference between a spring chestnut-sided warbler and a fall chestnut-sided warbler, if you're birders, they look completely different, right? One is bright and colorful, the other one is drab and green, and you might actually mistake them for two different birds. So it's not completely off base, but it turns out that was not actually the case. Another thought was maybe they went into hollows and hibernated for the winter because they'd seen other animals do that. They knew that was a possibility. Nobody ever found them in hollows, but they assumed that maybe it was possible. And there was even a theory that they actually went under lakes in the wintertime and hibernated in the mud. And then in the spring, they would actually come out of the water again. If you've ever watched barn swallows, they're these little kind of flitty blue and orange birds. They're beautiful. And they like to fly around water a lot. So maybe that inspired them to think that's what they were doing. This one is actually taking a little drink while he flies by. Swallows are kind of amazing. They're a group of birds that are aerial feeders. So they have these really big mouths so they can catch bugs in the air. And they're actually related to swifts. And they actually did a study of swifts in Spain where they found one that stayed in the air for 87 days straight, never landing. They can actually basically live on the air. They can sleep while they're flying, and they just feed on the wings, so they never basically have a reason to land. All right, so some people, 2,000 years later, we were still using some of these ideas to understand where these barn swallows went, and we still didn't have an answer. So some people did some studies where they actually thought, well, okay, so we'll test this hypothesis that they hibernate. They took barn swallows and put them into an ice house and got it really cold, and they wound up with a bunch of dead swallows. That was not really the answer. There was one person, I'm gonna have to look at my notes here just to remember his name. Charles Morton, Charles Morton in 1694 actually did predict that, or sort of describe that barn swallows did migrate long distances. The problem was that he thought they migrated to the moon. So another good guess, but you know, it all seems sort of ridiculous now, but when you think about if you've ever kind of just gone out looking at birds and tried to think without binoculars, without the knowledge we have, with just sort of walking around and trying to figure things out, it's not that easy. And actually this particular problem has been a really huge problem for people for most of time. By the way, this is a really neat thing. You can actually see birds fly across the moon. How many people here are birders or bird watching types? Okay, so you guys may have done this. You actually can take a binoculars or a scope and look at the moon. And during migration, which is in the spring and fall, you'll see little silhouettes of birds actually zip across the moon. And that's because they fly at night and they're migrating at night. So it's actually a way that they used to figure out how many birds were migrating on a given night is you could look at the moon and watch how many birds flew across it, and then you figure out how big the moon is compared to the whole sky, and then you multiply it by that, and then you say, okay, that's how many birds migrated last night. Do you have a question? Oh, no, sorry. Okay. Yeah, if anybody has questions, feel free to. So let's get to banding next. So this was sort of the next advance. Like a lot of things that Aristotle did, I give a whole talk on taxonomy about him. Like a lot of things he did, sort of those ideas sort of stuck with Western civilization for about 2,000 years. And then during the Enlightenment and around the 16, 17, 1800s, we started to discover some other hypotheses and be able to scientifically figure out some of these things. So as technology improves, so that holds true for banding. And actually, does anybody here know what banding is? How many people have heard of banding? Okay, so bird banding is what it looks like right here, and I'll show you. They basically take a little metal band and put it on the bird's leg and let it fly away, and then they try to catch it again and see where it was. One of the first examples of banding, this is in around 1600. So the King of France at the time had a falcon that they were using for hunting, but those birds actually had a kind of band on them. They had a leather wrap on them with a royal seal on it. This bird actually flew all the way from Fontainebleau in France down to Malta, and it did it in 2 days. And that's a distance of, I think, 1,600 miles, so or thereabouts, or 1,000 miles. So this bird flew all the way down there. I checked on Travelocity, so now you could do it in 26 hours by car, 2 hours and 45 minutes by plane. It would cost you $453. This bird actually did it, for free, and shot all the way down there, and was discovered down in Malta. And that was sort of thought of maybe sort of an early example of accidental banding, where they saw where this bird went because they saw it and caught it. This poor and odd-looking fellow is one of the Rochart storks, right? So these wood storks were birds that are common in Europe. You'll see them nesting on rooftops. They're big. They're like, maybe that tall. And they migrate to Africa in the wintertime. And these birds were actually, this specific bird was actually recaptured in Germany. So what happened was the bird left, and then in the spring, it showed back up and it had this arrow sticking through it, right? And it was still alive. And the arrow had a very specific form, and actually they knew that this arrow came from a specific tribe in Africa. So I said, aha, this bird went there or passed through there. And so that actually gave us information about wood storks go in the wintertime. And there's actually a number of these storks. There's probably like 20 or 30 of them. If you go to a certain museum in Germany, you can actually see a bunch of them. But it was another way that people kind of got a clue about migration early on. Now, does anybody know who this is? He's pretty dour looking, right? That's Audubon. Yeah, that's John James Audubon. He actually is credited in the United States for doing the first banding. So in 1806, I believe it is, he took a piece of silver wire, and he was watching one of these little phoebes, right? This is like a little flycatcher that we have here in the East. Eastern phoebe, you'll see them make little nests on houses and stuff sometimes. So he caught one and he put a little silver band around it, and then it left for the winter, and then it came back the next summer and it still had the silver band, so he knew it was the same bird. So that was one of the first examples of banding in the United States, so he's sort of credited with that. In 1902, this gentleman, Paul Barsh, did a larger experiment with black-crowned night herons, and they actually banded a bunch of them intentionally in Washington, D.C., and then saw where they went afterwards. He is actually, believe it or not, just a little pop culture reference, very closely related to Gomez Adams. You can see the resemblance there. I find them strikingly similar. In any case, he founded one of the early banding foundations, and that actually turned into the National American Bird Conservancy, which actually does a lot of the banding and controls the banding in the United States. It's an organization where everyone sort of reports their data to who's doing banding, and that way they can kind of have this clearinghouse of where all these birds are going and being tracked. So you can see here, this is actually a bird that's being banded. You catch them in these mist nets, right? So you have these mist nets that look like this. And these are all little birds caught in there. You usually set them up across like a path where the birds like to fly through. And you catch them. It doesn't kill them or hurt them. They get tangled up in it, though. And you have to have some skill. You have to know how to untangle them quickly and make sure they don't get hurt. You have to go through there pretty frequently. Usually when I've done banding, you actually check the nets every 15 minutes. So you walk through, take all the birds out, come back, do another round. And when you get the birds, you put them in these little cotton bags. And the bags, when they're in the dark, actually, they calm down pretty quickly when they're in a dark space. So you take that back to the table, or we have a little house where we're doing it. And you have a table where the bander will take the bird out. They'll make a couple of measurements about how long the wings are and look at the color and the plumage. They might measure the bill, and then they sometimes even take one little feather as a sample, or they can draw blood, depending on what they're trying to study. And then they put a band on them with a little pair of pliers. And, you know, depending on the size of the bird, they have different sized bands. So if you're a little tiny hummingbird, you got these little itty bitty pea-sized bands. And if you're a golden eagle, you have a band that's like that big around, right? So they put those on, and then they let them go. And if you do it quickly, the whole process just takes a few minutes. And we have days sometimes when we would have hundreds and hundreds of birds get caught and banded and released. If it gets too big and you feel like you can't keep up with demand, you don't want to have these birds in these bags for longer than maybe 30 minutes, at most maybe an hour, because it can, you know, you don't want them to have any dire consequences from you handling them. So you close the nets if you have to. But in any case, you band as much as you can, let them all go. So now you've got this bird with a little number on its leg, and you hope that someday that bird will be refound, either by another bander or by maybe sometimes by a hunter or a bird that is a window strike. But in any case, somebody who finds this bird recaptures it and gets information from it. As you might imagine, the return on this, that's the American Banding, North American Banding Council, right? Okay. And as you can imagine, the drawbacks to this are, one, you have to catch the bird, right? You have to have permits. They have a very strict permit process where you have to be, you know, this is an apprentice system. So if you want to learn how to do it, you have to learn from a master bander. You have to have a certain number of hours of banding before you can do it yourself. The data is just for one bird. So you caught one bird and you find out whatever that specific bird did. It requires recapture, and recapture rate is 7%. So that's a high recapture rate, actually. So it takes a tremendous amount of effort for a very limited amount of data. And then one other issue is that you don't know the route, and you don't actually know if the bird is at the end of its route or in the middle of its route, right? Because you catch the bird in one spot, and you let it go and say they catch it again in Central America. Well, is it because it was in South America coming back, or was point A where it was breeding, or was it above there breeding? And how did it follow the path on the way from A to B? We don't know, right? So it's a fairly specific kind of data. Now that said, it's actually probably the single most useful data set that we've created for understanding bird movements ever, right? So it's a massively useful data set. And part of that is because we've had millions and millions and millions and millions of birds banded, right? I think on average the number of birds banded in a year is 1.2 million, right? So since they started doing this in the 20s as part of the American, sort of the bird conservation, what's it called? The International Bird Conservation Doohickey. Where they, which was part of them actually, why can't I remember that? Anyway, the feather trade had actually decimated birds before the 1920s. People liked them in their hats and they used them for decoration. And so a lot of birds were actually disappearing or in severe danger because of this hunting and overhunting. And so they created this act that said you can't kill migrating birds. You can't kill most birds unless they're a game bird like a duck or so on. So you can't shoot egrets just for their feathers. And that holds true today. You can't do that. You actually can't even have a feather. So if you pick up a feather, like an egret feather off the ground, technically you're not allowed to have it. I won't tell anyone, but you're not allowed to have it. So that was actually part of what started the Banding Council also. So the Banding Council formed around the same time in 1920 or so. All right, so let's move on to the high-tech stuff, all right? So we've got banding. We started with observation, right? Then we did banding. Now let's go to telemetry. So telemetry is just using radio, basically. So you guys might have seen these. You have those, like, you know, if you ever see a nature show and they're holding up that wand that looks like that, and they're, whoa, okay, go back. They're holding that wand up and they're tracking some kind of animal and finding out where it is. Well, that's telemetry, and what you're doing is you catch an animal, right? Again, you have to catch it. You put a tag on it that has a radio signal and a battery, and then you can see where the animal is. And usually it's, you know, the most basic version is it makes a beeping sound, and it beeps faster when you get closer and not as fast, you know, when you're further away. And it's really good for big animals. So it was used a lot initially for animals like elephants, right, or deer, because these animals were big enough to hold the technology that we had in 1950, say, to put on them. We didn't have little lithium batteries. You'd have to put like a pretty big battery, and you'd have a pretty big transceiver to put on there. And so you couldn't do it with like a little bird or something like that. It was mostly used for mammals. I actually know someone who was doing conservation here in New Jersey in the Pine Barrens for rattlesnakes. And so they actually put them on rattlesnakes. What's that? Yeah, and so they have to, so surprisingly, these rattlesnakes travel miles, right? And so they could use this telemetry to actually track them and see what they're doing. So that's telemetry. It started sort of in the 50s and 60s. And MODIS is just a type of telemetry system, right? It's sort of a brand, basically. So MODIS is based in Canada, and it's a it uses two specific radio frequencies, basically, to for its transmitters. So it's sort of, there's a 400 and a 100 transmitter, and those transmitters can be picked up by these stations. So not only could you use, you know, people don't really use these little handheld things now. What they're using is a station with a big antenna on it, and the bird has a radio tag on it. And now the radio tags have gotten small enough, you know, since the 80s, 90s, and so on, that we can put them on birds. And if they pass within a certain distance, it'll pick them up. So this information is actually a couple of years old, but the number of animals tagged for MODIS is over 31,000. The number of full-size MODIS receiver stations, which are these big stations with big antennas and have a pretty wide range, is 1,350. So, and all these little yellow dots here are MODIS stations, right? You can see there's a big focus here in the eastern United States, but they're you know, expanding, and they're actually seeing more and more in Europe, and we're expanding more in the United States. So that's the organization, right? So the company that I work with, CTT, manufactures these tags, right? And they make all kinds of flavors of these tags. So they do make radio tags, right? And actually, this is a map of the local MODIS stations around here. So like, here's Cape May down here, and then we are up there, but you can see there's a couple of MODIS stations up in our area. Around this area, there's a ton of MODIS stations, and over here in Pittsburgh. So those are the MODIS stations that exist right now, and I'll talk a little bit about how we can expand that. But not only can we use radio, but we can also use things like satellite, right? So there's a few satellite systems up there. You might have heard of the Argos network, the Iridium network, like Iridium phones, which they use on Everest and places like that, so they can make calls from anywhere in the world because they're bouncing it off a satellite, although not like Antarctica for technical reasons. And this is a satellite tag on a redhead duck. So this tag actually has a solar panel. You can see it has a little antenna, and that tag is actually bouncing off a satellite and then sending that data back down to a computer somewhere and telling them where it is. They're really cool. They're also expensive, and they're getting more miniaturized. So, but you still can't put them on really small things. You can put them on, this is getting close to the size that you can put them on as like a duck, because it's satellite, it has a certain amount of technology it needs, plus battery power, so it uses a lot of energy because it's communicating with a satellite, so that energy, if it wants to send data through that, it's gonna need more than if it was just sending like a little radio signal to something close by. So they tend to be bigger. And actually, this is Mike Lanzone. He's the CEO of CTT, the company that I work with. And he founded CTT with the concept of cellular trackers. So we've got radio trackers, right? That means like a researcher wants to track something, so they put radio tags on stuff, and then they have to use the stations that are out there and get them picked up. We have satellite trackers, which are cool, but they tend to be a little bulkier and expensive. But he figured out cellular trackers. He said, well, why don't we use the existing network of cell towers, and we could just bounce data off of those from our animals that we're trying to study. And so he went and got a bunch of cell phones from his friends and broke them apart and sort of put them back together again and made a cellular tracker. And ever since then, we've been making these cell trackers as well. So this is a golden eagle that he's holding. And that's the cell tracker on the back, again, with a solar panel on it. And it gives you a tremendous amount of data, right? So we started with not knowing where birds went. Then we went to banding, where you go from like point A to point B, but you don't know in between. Then you get radio tags, which actually give you more data, but not as much data as you would like. And especially for a project like, that's the cell tower, like Mike was working on at the time, which was, they wanted to put up windmills on ridge lines, right? And they didn't know if the birds also flew along those ridge lines. And the thing is, he needed pretty detailed data to see that, right? So if you have a radio tag that only beeps every 5 minutes, say, well, in 5 minutes, a golden eagle could fly a dozen miles probably, right? So that means that you don't still really have the information you need to say, well, we could put our windmill here or here without hurting it. So he actually worked out this system that gave him a tremendous amount of data. So you can see, this is an actual data tag from a cell tag. You can actually see the path of the golden eagle in magenta here, and you can see it actually go down, and then it actually spirals up. That's called thermaling, where they sort of soar up using hot air like an escalator, basically, get to the top and then soar down. You can see all the little points. He's getting a point of data like every couple of seconds, so he knows exactly where they were going then, and that made it possible for them to make a determination about a wind farm. So that's actually something that all wind farms and other environmental projects like that have to do, is they actually have to do an environmental impact study like that. So, oh, shoot, I don't want you guys to miss that. This is really cool. This is an actual pair of tracks taken with a cell tag. And these are two golden eagles. One is called Trace. I think the other one's called Coondog. I did not name these birds. Very strange. But in any case, you can actually see them flying and then run into each other and actually travel together for a minute and sort of pair up, go up this thermal, and then they split off and go in opposite directions. So, pretty cool, right? I mean, all this from just having that little tag on their back. You can see really exactly what we're doing. And a few years ago, we had a whole bunch of snowy owls. Snowy owls are these beautiful white birds. You know them from Harry Potter. It's Harry Potter's bird. They live up north in the Arctic, right? You don't see them in New Jersey. They're very rare here in New Jersey. But they're very common up in Canada, for example. Well, we had what we call an incursion, where we actually had a ton of snowy owls come down into the States a number of years ago. And that gave people an opportunity to actually study where all these young snowy owls were, how they were behaving. So they caught a bunch of them and put receivers on them. And this is actually a snowy owl track, believe it or not, in an urban setting for some reason. And you can see all the things that it did. So what's really cool is we can not only see exactly where it went, but we put accelerometers, and we can see the motion of the bird. We can see when they're turning or stopping or sitting still. And so that actually, we can use that information to determine what their behavior is. Like, we can tell if they're eating, or if they're nesting, or if they're sleeping. So not only can we see where they are, but we can actually start to infer what they're doing. So that's really cool. Let me tell you one more really cool thing. So the limitation with a lot of these things is how many stations are there out there, right? Do we have a cell tower everywhere, so that if this bird goes up into Canada, are we still going to be able to pick up data from it, or is it just going to disappear off the map because there's no cell towers? We can use satellite, like I said, but satellite is only good for bigger animals. They're also very expensive. So we came up with this concept at CTT called the Internet of Wildlife, and it's kind of a play on the Internet of Things. The idea is that we actually use the birds to work with each other to collect data. So we have a turkey vulture, right? This is a great, vultures are great. A lot of people, they have a bad rep, but vultures are really cool. They're very great, they're great parents. They're actually very social animals. They're very smart. In any case, big birds like this can carry a big data pack that has a lot of power and can transmit for a long distance, but it can also receive, right? We can put a lot of memory in there, okay? So we put one of those on that guy. If he passes by a cell tower, great, it tells us where he is. Now, here's the cool part. If we have a yellow warbler and it's singing and it has a smaller radio tag on it that doesn't go very far, and that vulture passes it, the two tags talk to each other. So the data from the yellow warbler gets uploaded to the data on the turkey vulture. Now, the next time, or the data on this cute little turtle down here gets communicated to that turkey vulture, and next time that turkey vulture passes a cell tower, all that data gets downloaded. So where that's really useful is if you have birds that go up into the Arctic, for example, and they'll disappear, but if we have a golden eagle up there with a pack, it'll still be picking up data from those little birds that have small packs on them, and then when that golden eagle comes back, it'll hit a cell tower and drop all that data down on us. So we'll get this big dump of data. Yeah.
Yeah, I know not the turkey vulture because they only eat dead things, but what if you had it on the hawk and the hawk ate the bird that had the cracker? No, but it's like, would it harm the hawk? Would it
Oh, that's a good question, actually. I very much doubt it. So like with a bird like a eagle or a hawk or an owl, a lot of times they'll cough that stuff up. So if they eat something like that, they'll just, they'll sort of digest it and cough out the bones and stuff. So, and they also, birds have crops, which are actually very powerful muscles that they use to crush things. So I think it would be okay. But that's an interesting thought. I don't think it's happened yet. So I don't think I don't think it'll be common, but we'll keep our fingers crossed. I'll be very curious to see if it does happen. Yeah, and also what had happened with like a hawk is when they kill something, they usually pick it apart. So they might do that and sort of decide they don't want to eat the tracker. Now, here's some cool stuff with telemetry. This is sort of the latest technology, really the latest because it's only happened in the last few months. CTT has created these butterfly tags, right? So we worked out these Bluetooth-based tags. They have a range of about maybe 500 meters, and they have a little solar panel on them. They are very, very light, as you can imagine, so light that you can put them on a butterfly without interfering at all with its lifespan or its activity. Right? So the rule is generally you don't want to put more than 3% of the weight of the bird in a tag, because if it's more than 3% of the bird's weight, it'll actually create issues for the bird during its life. It might interfere with its behavior. It might put stress on it. So this is less than 3% of a monarch butterfly. Can you imagine how small that is? And we actually banded something like, I think it was 76 butterflies on an event that we did in November, October. And now those butterflies are all over the place, and we're able to track them. We've actually got a bunch of hits back from people by using an app. So what we did was we created an app called Project Monarch. Yep, you got it. And if you have that app and you're outside and you hit the button, it'll search for tags, right? So if you go in your garden, there's a bunch of monarch butterflies there, you can hit the button and see if any of those are tagged. And then if they are, it'll share that with the central database and we'll know what these monarchs are doing. This is really important actually because especially around here, the monarchs are declining rapidly. So we're not totally sure why actually. We're trying to figure that out. And our standard Bluetooth, yep, exactly. So yeah, it just uses the standard Bluetooth protocol. So one of the cool things about the project I'm working on is these devices we're making will actually pick up these tags. And actually 2 days ago we decided, or 3 days ago I guess, they decided for sure that we're creating bat tags as well. So we're gonna make tags that are small enough to put on a bat that'll do something similar. So, okay, so that's great because, you know, conservation in terms of the real world, in terms of really protecting stuff, is driven by information, right? You go to the government, you say, we really need to protect this field. Like, this field has tons of stuff in it, and we really shouldn't put a condo there or a golf course. And they say, okay, well, what evidence do you have that that stuff is there? Why should we listen to you? We need to see numbers. We need to see trends. We need to see, are there endangered species there? So that information is critical for actually changing policy. So by having data like this, we can actually start to affect policy. And part of the problem in the past, or at least, you know, and still, is that sometimes these research projects, they're limited by funding, right? They're limited by manpower, woman power, person power, I should say. They're limited by, you know, interest, sort of like who wants to do what. So, you know, if you have a team of researchers and they're most interested in X or Y, then Z over here is probably not going to get as much attention or funding, right? So, and that's because we have limited resources, and that, you know, that's how things work. But if we're trying to do as much conservation as we can, the more information we can get, and the quicker we can get it, the quicker we can actually, you know, work on protecting the areas that need protecting. So, that said, first let me just go through the drawbacks of telemetry. First of all, they need even more effort and expertise than banding. Like, you need to know how to put one of these things on a bird, and not a lot of people know how to do that, right? They're very expensive. They range between $200 and $5,000, and actually marine tags can be as much as $45,000 a tag, right? So you're talking about huge amounts of money. The data, again, is just for one bird. Even though it's very detailed, we're only getting information about one bird's behavior. Okay, so let's go to community science. So community science was a way actually to collect more data and get more information. Anybody here ever hear of eBird? Okay, so eBird is a system created by Cornell to allow people to report the birds they see. Right? So if you like birds, you go for a walk, you go on you could write it down and then go home and put it in the computer, or you could use the eBird app and you say, okay, I was at so-and-so park, I saw these birds this morning, you submit it, eBird says, thanks, keeps that data. It now has almost 1 billion data points that it can use. So it has just a tremendous amount of data being created by people, right? So this is the power of community science. So great, now we've got this, we're mobilizing this sort of force of people to go out there and do community science and bring in this data that we need. Here's some people doing that, and I think that the other amazing thing about community science is that it actually creates communities. Right? So it brings people together with similar interests, and it creates these communities that are excited about nature or wildlife, and it helps sort of strengthen the community as a whole in those ways. I think it gets people who are curious, you know, kind of get more into it and get more excited about it. And I think the more people that are excited about conservation, the more conservation we're going to do. So there's a bunch of apps and stuff for people to use when they're doing this kind of stuff. eBird, I snuck in the Warbler Guide app there. Has anybody ever used iNaturalist? Okay, yeah. If you guys haven't used it, you should download it. iNaturalist, you got iOS and Android, and you can just take it and take a picture of any natural thing, okay? Take a picture of a plant, a bug, a bird, an animal, and just say, what did I see? And it'll tell you what it is, right? It's pretty amazing. It's pretty close to magic. So like, I don't know plants very well, and I use it a lot with plants because I want to know more about the plants that I see. But if I really want to know the plants, and I have like one of those big heavy guidebooks for the plants in my area, and by the way, most of the plants in my area are going to be exotic or invasive, so they're not going to be in that book because I have a native book. I try to look it up. There's a lot of problems with the amount you have to know in order to be able to just start, right? So like, how am I going to identify this tree if I don't know anything? Well, iNaturalist sort of gives you a foot in the door. And it's not always right, but it does actually get you started, so you can say, okay, You know, I know it's in the holly family, and maybe it's not, it didn't get it exactly right, but now I'm starting to see the differences between these different plants. I'm starting to learn about them, right? And that's part of what these educational apps and tools are doing for us, is they're helping people get a foothold and an entry into learning about these natural things that they want to learn about without having to be experts, right? When I co-wrote the Warbler Guide, we did it in a way because in part it was in a response to the books that were already out there, which I had learned on, which you can learn on, and which are good in some ways. But basically, if you ever pick up a bird guide, most of them are just bird dictionaries, right? So it's sort of like trying to learn English from a dictionary. And so the premise becomes basically you have to learn the whole book in order to know any given bird. Because you'll flip through it and you'll say, oh, that sort of looks like the bird that I saw. But then you'll say, I wonder if there are other birds in this book that also look like that. And then you'll have to flip through the whole book until you see if there's another one. And then you have to compare them and so on, and they're on different pages, and it doesn't make sense. So they're not great learning tools. They're great sort of, no, they're bird dictionaries, you know. And I love them. I mean, I learned how to bird on them. But these tools that we're starting to see developed out there are making it a lot easier for people to get their foot in and just say, I just want to know what that bird is at my feeder, and it tells you. And then you might say, oh, now I'm curious what that bird is, and so on. Merlin is another great, if you're into birding, is an awesome birding tool. It does a couple of things. It'll ID any photo you put into it. If it's a bird, it'll also identify bird sounds. So if you hear a bird singing, you can press the button, and it'll tell you oftentimes very well what bird it is. Okay, so, and there's a lot of websites and stuff. Cornell is sort of the main university that does this stuff. They've used all this data that they've got from individual people to build these maps. So this is a dynamic map of a bird that actually we started this lecture with. This is barn swallow. So if you look here, here's barn swallow in the summertime. This is where the Romans are hanging out watching the barn swallows in the lake. And then they leave. Look where they go. Right, all the way down to the bottom. So no wonder they didn't know where they went, because they were going thousands of miles south. And that's one of the amazing things we've learned about with migration, is that these even tiny birds like hummingbirds, warblers, which are these little tiny birds, fly thousands of miles every year going to maybe the upper parts of Canada into Brazil, and then turning around and going back again for blackpoll warblers. So you're talking about little tiny birds that do these huge flights. And they do it just every year. That's just their routine, right? So that data has given us a lot of information that's super useful. So drawbacks. Uneven coverage. If you live in Cape May, where I do, there's a ton of birders there. It's a very popular birding spot. It's very well covered. There's lots of people out there looking at birds. If you live in Montana, then there's probably some pretty big areas that aren't being covered there. Or if you live in the boreal forest, you know, in Canada, even fewer people are covering things there. So we don't necessarily have the same amount of data from every place. Data's not always reliable, and it's because the birders aren't always reliable, right? If someone's a brand new birder and they look at a bird, they might not know what it is, and they put it in and it might be wrong. And it still requires people's active participation, right? So it's much less of a barrier to entry as banding and other stuff, where you have a high level of expertise and it's very specialized. So anyone can do eBird, right? You can just go out, get a list, write it down, put it in there, and it's done. But you still have to do it, right? You still have to go out and do it. It's not automated. So here comes bioacoustics. Okay, so now we're at my wheelhouse here. This is Project Terra. That picture there is of a Terra, and that's the app that is a companion to it. So bioacoustics, you know, oh, okay, so here's this, sorry, this is my big moment. How many people here have ever banded a bird? All right, excellent. How many people here have ever put a radio tag or other tag on a bird? No? I had somebody say yes at the couple of months ago. How many people here have heard a bird? Okay, good. So that's the power of bioacoustics, right? So bioacoustics is, all it's doing is listening to the sounds that are out there and deciphering them for us and telling us what the birds are doing, right? Now, birds make sounds, and a lot of birds, so they sing, right? We've heard birds sing, and it's actually a really nice time of year right now. You hear all these cardinals and other stuff singing. I love this time of year. But they also typically make little calls too, like a cheep or a chip, right? So I don't know if you'll hear this. Let me try. Nope. So I'll do it for you. Like a redstart would do like a tss, right? And a Blackburnian warbler here would do like a tss. And a green heron would go right? And then a meh, 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 that's a dickcissel, okay? So these birds make these little sounds, and they do it when they're migrating. They're called flight calls, and they're sounds that these birds make when they fly. That's why they're called flight calls, basically. And so these birds, when they fly overhead, most of them fly at night, and if you are there when they're flying and they make these sounds, you actually know which birds they are, because every one of these birds does a different sound, okay? So that's great, because that means that if you know the sounds well enough, you know what birds are going by, right? So that's what bioacoustics leverages. It uses this gift of sound that the birds give us. Yep. Mm-hmm. I know you're starting to get the idea. That's my idea too, which is that we can use these sounds and put them in your own backyard and get the data. And not only that, but you don't have to do anything. You just stick it there, leave it, it runs. And that's what Terra does. Terra is a device that has a pair of microphones in it. You stick it in your yard, stick it on your roof or your wall, and it'll actually listen 24 hours, 7 days a week. If it hears a bird sound, if it thinks it's an animal sound, it'll actually clip that little piece of sound. It'll send it to get analyzed, and it'll say, oh, that was a cardinal, or that was a sparrow, or that was a so on and so forth. This is what the picture of the sound looks like. This is called a sonogram. This is a picture of sound. And if you look at these, you can see how different these different sounds look, right? And actually, it's kind of interesting. The way Merlin and other sound ID tools work right now is they actually make a picture like this, and then they compare the pictures. They're not actually comparing the audio file, they're comparing the picture files, and that's how they tell them apart. So they say, okay, that's definitely, a song thrush, a moorhen. Song thrush isn't a bird in this country, but an oyster catcher, a whimbrel, we have those. And so you can see the differences between them. This is some friends of mine in Cape May about 15 years ago, and we started making these microphones because you can. If you go online and look up how to make a night flight microphone, because they call these night flight calls, that's what these are, because they're flying at night. You take a bucket from Home Depot or wherever, you get a cheap microphone, you stick it on a plate like this, sort of tape it in there, you have it pointing down into the plate, you put it into the bucket, and then you pour concrete into the bucket so that it makes a weight and sort of secures the device there for you, and then you wrap it in plastic wrap. And if you wrap it tightly in plastic wrap across the top, it becomes basically sonically transparent, but also waterproof. And you put that on your roof. And then the wire that comes out the bottom from the microphone goes to some kind of recorder. And people who were doing this in early days were actually using VHS recorders to do this, right? They'd use VHS tapes that they would have to change every 60 minutes or 120 minutes or whatever. Now, of course, we can record them directly to a computer, and we can even watch the sonogram as stuff flies over and analyze it. The problem with these was that we would do this, we would set it out, we'd record a night's recordings, but then you have to listen to it. So now you have to listen to a night's recordings, and you can accelerate that a little, but you basically have to look at it and have someone who's good at it pick out what the different birds are, and then they can tell you. But it's this kind of a specialized skill again, so you've got this bottleneck again. here is two pictures of two different sounds. So this is a thrush, which is going to go like, and that's more like a sound. So sonograms, if you see a little up and down like that, it's a bzz, and if you see a straight line, it's like a clear sound. Yeah.
So when a mockingbird sings, does the picture look the same as the bird they're imitating?
That's a really good question. It doesn't exactly. So it's going to look, the thing is, if you listen to a mockingbird or a catbird or a brown thrasher, which are all mimics, right? So they'll mimic other birds. Starlings actually are really good mimics. And actually, starlings are a great example because they're really good mimics. If you listen to them closely, they're mimicking other birds, especially this time of year. But you can always tell it's a starling because there's a starling voice that's happening. That's sort of the timbre and the way that it sings gives it away, right? Now with mockingbirds, they're much closer to the bird song, but it doesn't look exactly like it. Yeah, if you look at them side by side. Yeah.
Why did they do the imitation?
So there's a number of theories about this, right? One of the most popular theories is they think that birds who mimic are actually, it's a way for the males to show fitness, right? So in terms of getting selected during mating season, they're showing that they actually have experience because they learn the sounds over time. So the bird that's able to do the most imitations and also do sort of the loudest and most correct imitations, that means that bird is healthy and also it's already lived a few years or lived at least a year to collect songs, which means that it's, you know, a good mate. Whereas a young bird who's just been hatched will only know a few songs that might not sing them very well. Birds actually a lot of birds learn their songs, and they, believe it or not, if you hear a bird singing, it sounds, if you hear young birds learning their sounds, it's really fun to listen to because they sound sort of like what they're going to sound like, but not quite. And they actually have to practice that skill to get good at it. They don't just do it. There's some birds who do basic songs do, but most birds who do these fancier, more complex songs, they learn them, right? So I'll tell you one cool fact. So cardinals, right? They do a long, clear sound. So they go, right? So it's long slurs. We call these clear slurs. And if you look at a sonogram, it'll look like a long straight line that sort of curves up, right? Well, birds have two syrinxes. They have two voice boxes, so they can make two sounds at the same time. That's why you can't imitate some birds. It's because, especially things like starlings, they make these bizarre sounds. It's because both voice boxes are working at once. So maybe if you had a partner and you could like perfectly, you know, synchronize your singing, maybe you could do it, but you can't do it by yourself. Well, cardinals, when they sing that really long sound, they're using one syrinx to do the bottom half and the other syrinx to do the top half. And getting those two to match perfectly is a skill that adults develop. And so it's part of how you can tell if it's an adult bird, if it's doing that perfectly smooth sweep. If you have a young bird, you sometimes will hear it actually break that sweep. You hear like a like that, as opposed to a right? So, okay, little bird nerd fact of the day. Okay, so, it played it. Okay, so that was that one, I think. Yeah. Bioacoustic advantages. Why is it so great to use bioacoustics? All you have to do is listen. You don't have to touch the bird. You don't have to catch the bird. You don't have to handle the bird. You don't have to have any expertise with birds. You just have to listen to them. Many, if not many birds sing. This isn't going to work on every bird because some birds actually don't make much sound, but for a large majority of them, it will. It's instant, right? So the way we're working it out, using a computer to do the identification instead of a person, you'll actually be able to instantly see what birds are going ahead. You can do a real-time view of what's happening in a migration. Now scale that up. You can do it for what's going over your house, right? Okay, robin just flew over. I just heard a veery fly over and a bluebird fly over. We'll now expand that to the 2,000 teras that we've actually already pre-sold, expand it to the 5,000 to 10,000 teras we expect to sell this year, expand that to the 20, 30, 50,000 teras we hope to sell in the next 3 years. Now you've got that times 50,000, and you have a picture of migration across the whole country and actually across the whole world, right? So we've got this way of seeing entire populations at once, right? We can't do that right now. We can see individuals and sort of guess from those individuals what the rest of them are doing, but we can't see the whole population at once. Yeah. Yeah, it's true. When you're in a city, you're going to have more issues. But part of what we're working with is doing a lot. There's a lot being done with digital filtration, so we can actually pull a lot of sounds out that are not bird sounds, even in a city. Luckily for us, most bird sounds are higher than human-made sounds. So like voices, automobiles, air conditioners, that kind of stuff, those are all at low frequencies that you can cut out really easily. And when you do that, especially if you place it up on your roof so it's got a good vantage, you can actually, I lived in Brooklyn for 15 years, and I used to go up on my roof and I could listen to the birds migrating overhead. Yeah. So you would think that you wouldn't be able to get anything, but actually you can. Yeah. So it won't work with bats right now, but it will. So we very much are going to have a bat one, or have a way to do it with bats, but you need a special kind of microphone to do that, and this is our first version, so we haven't put a bat microphone in, but we will be doing it for sure. Yeah, that's a big interest of ours. So that's the Terra project. Just to wrap this up a little bit, so what a Terra is this device. You put it in your yard. It has a radio tracker in it. It has a sound pair of microphones in it, so it'll let you ID birds. Not only that, but it actually lets you listen. So this is a whole nother side to it. Actually, I should have more here. Yeah. Please.
When are these going to be ready for prime time?
We're starting to ship in June of this year. Yeah, June. Yeah, if you go to terralistens.com. Terra Listens, Terra, listens, listens.com. And you can find out more about it, and you can order one there. It also has these little sensors here. So you actually have a soil sensor, so you can put it in your garden. It'll tell you when you need to water your plants. It'll tell you what the temperature is. It'll tell you how much light is hitting it, and a weather sensor to tell you temperature and humidity. These actually are accessories you can buy, and we're doing it because we want to find out also about the habitats where the birds are flying over a little bit more. So it'll be a benefit to you if you're a gardener, like I am, but it'll also be a benefit to us because we'll get a little bit of habitat data too. Yeah. It uses a Wi-Fi connection. Yeah, so basically it acts in a similar way to Ring Doorbell or Arlo or any of those outdoor devices that you use, like outdoor cameras. And you need internet, yeah. That's going to be something in the future too that will probably change for researchers, but right now it needs internet, yeah. We have a solar panel accessory actually, and we're actually working on it right now. We're building it in-house, so we'll have one, yeah. So Terra, you put it in your yard, and if a bird is singing or if a bird is flying overhead, it picks it up. Or radio tag birds too, or butterflies. It sends it to the Terra network, which is a central database, so we can collect it all, and then the data is going to be available to researchers. So we're working out how we're going to share this data, but we're actually, part of our mission is to share this with researchers and conservationists so that they can actually use this data in an actionable way, right? We'd love to see this data used in a way that will help protect and save birds. And it'll also let you listen, like I was saying, to the sounds in your house. So you can stream the sound in. Like I like having the windows open, right? I like hearing the sort of, we live by the woods, it's nice to hear the nature outside, but we can't always do that because of the pollen, or it's because it's cold out, or it's too hot out. So we close the windows, but it's really nice to be able to still hear what's going on out there, right? And this allows you to stream it through your phone, so you can use the app to stream it to headphones or your speakers or however you want to do it. Let's see, so what does it do for so that's sort of what Terra does for birds, right, in conservation. It's going to be a very, very powerful tool. For people, there's an app that lets you actually automatically identify what you're listening to, and also not only listen to your yard, but listen to places around the world. So we're setting up these curated sites. We've got one already at Panama Lodge, or at Canopy Lodge in Panama. We've got one in Cape May, obviously. We've got one in the UK. We've got one that's going to a place in Nebraska where the sandhill cranes migrate, the Platte River, where they have these huge congregations of cranes that make these awesome sounds. But we're going to have a lot of these out there, actually. We're going to have dozens of these around the world at different eco-lodges, probably. So if you want to listen to the rainforest, you know, or listen to a watering hole in Africa, or listen to a waterfall in Hawaii, you can actually just pick the app up and listen to it. So to me, it's a great benefit. There's a lot of information that we're starting to see now that shows the benefit of listening to natural sounds, how it's good for stress and anxiety, how it's good actually even for outcomes after surgery. It can be good for heart rate and you know, physical attributes that people have, like some physiological things that people are dealing with, especially in a healthcare setting. So we're actually seeing benefits to that. There's a lot of ways that it can help people just physiologically and psychologically. If you're at home and you want to listen to stuff, you can use Alexa. We actually just set it up. We set it up with Alexa. It's one of the first things we did. So you can say, like, how many birds flew over my house, and she'll tell you, or Alexa, turn on my backyard, and it'll turn it on. Another thing, like I was saying, in terms of benefits, one of the health benefits is psychological, and one of the things that the United States especially is dealing with right now is a lot of stress, anxiety, and depression, right? I actually run a peer support group for people with depression and anxiety. I've had depression and anxiety throughout my life. It's fairly well managed now through medication and so on, but I think that I know that any tools that we can give people to help ameliorate some of the symptoms of these very painful diseases is good, you know? And I certainly don't think that Tara is going to, these are some kind of shocking statistics. 21% of adults experience mental illness in the United States, 1 in 5 people. 6% of them are experiencing severe mental illness. So those are scary numbers. And actually, the number for depression now is at 29% was the latest Gallup poll that I saw. That's a huge number, 1 in 3 people, right? So I don't think Tara is something that's gonna, you know, it's not gonna cure cancer, it's not gonna cure depression certainly, but it's a tool that'll help people focus and reduce anxiety, maybe help, you know, again, help sort of be one of the ways that they can, you know, get benefits. Decrease stress and annoyance, decrease pain, improve mood, perform better on cognitive tests. They've actually shown that listening to natural sounds help people perform better on testing. And just to go back to conservation again, so there's, okay, this is a funny number. This is how many birds there are in the world, according to the data we have right now. It's somewhere between 50 billion and 430 billion, okay? So in other words, we don't know. And, you know, it's a pretty big difference. And I think that one of the things Tara's going to do is give us a much more accurate number about population statistics, but not only that, but it'll tell us in real time as they change, right? So if we have, I mean, we'll see changes in population year to year. We'll be able to keep a very close eye on that stuff, and we'll be able to act more quickly as well because of that. One other really cool thing that it does, this is radar map. If you guys don't know, for some of you who are not birders, you might not know this. If you look on a radar map, if you turn on your radar, you know, app on your phone during migration, like in the next 2 months and also in the fall between maybe late August and November, you'll see these little blooms sometimes that happen on the radar, right? You'll see these little, see all these little sort of little pies that are expanding, and you'll see them start small and they get bigger and bigger. Those are birds. Those are birds that are migrating that are getting picked up by the radar. So we can actually see volume of migration right now. And there's even an app called Birdcast, which will tell you how many birds it thinks are going to be in your area on a given day during migration. But they don't tell you composition. So instead of just saying, well, we had a big flight, we can say there were 4,300 red-eyed vireos, 64 swainsons. We can do a whole composition of what the migration was, as opposed to just saying, well, there was a big migration. We don't really know other than that. Also, we see 1 billion birds die by bird strikes every year. So this is from skyscrapers and windows, birds flying into buildings. That's a huge number. And in certain cities right now, in Texas, I think Chicago's doing it. I know New York City's doing it to an extent. When they know there's going to be a big migration event, they turn the lights off in the buildings, and it prevents bird strikes. Because the birds don't think they can fly through the glass because they don't see something on the other side. So it actually reduces bird mortality significantly. And if we use Terra to do that, we could actually do the same thing. We could create an automated alert system for things like wind farms, skyscrapers, so they could actually adjust what they're doing to help prevent bird deaths. Yeah. It's interesting, right? I know you don't see them unless you go out and collect them, and the people go out early in the morning and collect them. I knew people when I lived in Brooklyn who would go to like certain buildings and collect them. I think what happens is they often get eaten, or they just get picked up as trash and thrown away, so you don't see them. And it often happens early, so unless you're out early, you don't see them before they, the cats get them or whatever. But it is actually kind of amazing how many birds. If you go online and say like pictures of bird strikes, you'll see pictures of 1,000 birds from one building. So yeah, yeah. The numbers are kind of mind-boggling, and they don't seem right when you first hear them. They seem like that's not possible. There aren't even 1 billion birds, right? Well, there are 1 billion birds, as I showed you before. There's at least 50 billion, and when you compound it across the whole country, through every city, the numbers get really big. So you can see here's some of that number of 340 million is actually much higher now, we think. Okay. I'll tell you one more really cool thing. We can tell not only what birds are flying over, but we may even be able to tell what age and sex they are. We've done some studies, actually, people at CTT have done studies about magnolia warbler, where they can actually tell not only that it's a magnolia warbler, but that it's a young male or an adult female, so we can see not only the species, but the age and the sex. Yeah.
Can you tell the difference between the same type of bird?
Yeah. Yeah, it's amazing. It's just, they're doing these sounds, right? But you can tell them apart. And actually, it's not as hard as it sounds. I'll do an example. So like a male magnolia warbler in flight sounds something like, right? And then a female will sound like, so you can see they're like completely different. It's very subtle. You have to look at a sonogram usually to tell them apart. But yeah, they are, that is happening. Another great advantage of using bioacoustics, especially, specifically Terra, you can see that number of 1,350 MODIS receivers in the country. Well, if we sell 10,000 Terras, there's going to be 13,500 MODIS stations, right? It's going to vastly expand the network that allows us to pick up all those radio tagged birds. It also helps us do point counts. So you can spend, you can buy 1 Terra and you can stick it somewhere and it'll do a survey for you. It'll listen all the time to what's going through there and tell you what birds are there. Yeah.
You project that once this learns all this stuff, that for us ordinaries, the sound that we hear in the night, it can show us the picture of the bird.
Yep. Yeah, it'll do it during the night and during the day. So if you hear a bird song and your Terra's on, you can just go to the app and it'll say that was a cardinal, that was a chickadee, that was a whatever. And it'll also tell you like you had 400 birds fly over last night and these were the birds. This was a new bird for your yard. Did you know that, so on and so forth, all those statistics. So point counts are another important area, yeah. And then like you were asking me for, bats, frogs, small ground squirrels, and cicadas. Anything that makes a sound we can study, right? So this tool is going to allow us to not just study birds, but allow us to study all these other kinds of animals as well. And we really hope to build a system that'll allow us to do surveys and understand better all these different organisms and how they need to be preserved. That is it. So thank you very much, guys, for joining me tonight. And can I answer any questions? Anybody have any questions? You could, yeah. All you have to do is basically plug it in. The question is, are they portable? Yeah, you can plug them in and attach them to your Wi-Fi, and that's it, and then it works. So you just need Wi-Fi and a power source. And we do actually, like I said, we're creating a solar panel for it, and eventually there will probably be a version that will just record to a card, so that if you're not near Wi-Fi, you can take it and put it, in the middle of the forest somewhere, let it record for 2 weeks, and then go get the card and see what was there. Also, we'll probably have, you can do point-to-point Wi-Fi, where you can do basically like 2 little antennas pointed at each other, and then you can stretch Wi-Fi a couple of miles, maybe 3 miles. So you could have a house with Wi-Fi and put this 3 miles away, and it would still communicate with your house. Is there any... Birds dying crashing into trees. That's an interesting question. I don't think so, because the reason birds die crashing into buildings is the glass. It's the reflection. Yeah, the wires. Yeah, they don't see the wires. And what happens is they'll fly through the wires and they'll hit one and it'll break their neck or something. Say that again? Snow geese can get up to like 25, 30,000 feet. Yeah, they can go as high as a commercial airliner. Snow geese. Yeah, certain geese can get way, way up high. And actually, they fly over the Himalayas. So that means they can fly like over Mount Everest. Yeah. Yeah. Amazing. Yes? How much is your device? $249. So we try to create a price point that's sort of accessible for people. And that way, we can get as many of them out there as possible. Any other questions? Guys, again, thank you so much, and hope that was helpful and interesting. Okay.